this video, we're going to look at displaying and describing categorical data. Before we really get into how to display and describe categorical data, it's important for us to be able to talk about some vocabulary that you're going to see throughout the course. One of those words that's really important is the word data, which we've seen and heard a lot. We live in an age of technology and an age of information, and we have lots of data all around us. And basically, data is any collection of numbers, characters, images, or other items that provide information about something. So think of data as values along with their context. If you've ever provided information to Amazon or to another company where you're ordering something, you are giving the company data. You're giving them information. You're probably telling them your name and your location and what you're interested in, and things like that. And all of that is data, and all of that can be used for specific reasons. So whenever there's data, we need to understand that data, and that's where statistics comes in, because there's lots of ways to look at data. If I want to know what is statistics as opposed to what are statistics, statistics is the subject. It's a way of reasoning along with a collection of tools and methods designed to help us understand the world. Now, when I say what are statistics, plural, that's actually the calculations that we're making from the data. When we have data, there's three things you always want to do with it. Make a picture, make a picture, make a picture. So the first instance helps us to think about the patterns and relationships. The second make a picture helps us show important features and patterns. And the third make a picture helps us tell others about the data. It's very important after you have your findings to then be able to determine what you found and then be able to explain it to others. So you're going to see this common think, show, tell throughout the book. And you're going to want to remember that when you're solving problems. The reason we create graphs is for two reasons. One of them is to understand the data better ourselves. And then the second way is to show others what we have learned and what we want them to understand. We need to be cognizant of what's called the area principle when we're creating graphs, though. And basically, the area principle just says that the area occupied by a part of the graph should be proportional to the magnitude of the value it represents. So what does that mean? Let's take a look at an example here. So here we have a graph, right? It's not a typical looking graph. It's a graph made up of the Titanic ship. So what impression do you get from the figure to the right, which should represent who was on board the Titanic? We've got the crew, the third class, second class, and first class. And then this represents the number of people there were for each group. So take a few seconds and you can pause the video and write down what do you notice about it, and then unpause when you're ready. So if you look at the graph, it appears that most on board the Titanic were crew members because the crew has the largest ship there. But in actuality, they make up only 40% of those on board. So the other 60% were made up of third, second, and first class individuals. So if you look at this, it appears that most people on the Titanic were crew members because it has the largest ship compared to these other three. But that is not the case, okay? Because the crew is only 40% of the ship and these make up 60%. But you can't tell that from the graph, so it violates the area principle. Characteristics recorded about each individual or data value is called a variable. So if you've taken algebra or geometry or any other math class, variables are your unknowns. Well, they can be unknown in statistics, but we don't usually represent them using the letter X. So you want to kind of think outside the box there. Variables here are just characteristics. When you are ordering something from Amazon, the company doesn't know your name yet. They don't know what you're interested in yet. They don't know your location yet. So those are unknowns, but they're characteristics about yourself that they find out. Some variables just tell us what group or category each individual belongs to, and we call those variables categorical, okay, which is very fitting. Those are also known as qualitative variables. So you could see either of those two words to mean the same thing. An example is like if I asked you who your cell phone provider was. Do you have Verizon? Do you have AT&T, T-Mobile? Another example of a categorical variable could be like what state or country were you born in? What is your marital status? What's your gender? What's your sex? All those are examples of categorical variables. They're really easy to summarize in what's called a frequency table. So the word frequency just means counts, like how often something occurs. And it lists the categories and how many cases belong to each category. We also have what are called relative frequency tables. And the only difference is that they display percentages or proportions rather than counts. Tables like these show what we call the distribution of a categorical variable because they show how the cases are distributed among the categories. And when we use this term cases, we're talking about like individuals. It could be, if you're doing an experiment, we could have like subjects and participants. Etc. Okay, so we're going to collect some data, and since this may be for my online class, we don't have the data right now as I'm creating this video, and we're going to create a frequency table and a relative frequency table. So I'm going to make up some values and show you how you can create these things. Okay, so the question is, what is your cell phone carrier? And I'm going to just write down some information here. Okay, so to create our frequency table, I've got one column. It's going to be called cell phone carrier. And the column next to it is going to be the count or the frequency. And if we wanted to, we could do a survey of the class and find out who your cell phone carrier is, okay? But since I'm doing this video before class starts, I don't have the data there. Here is some data for you. So some carriers could be like AT&T, Verizon, T-Mobile, and then we'll just say other, okay, because I know I'm missing some. And let's say we've got 8 people who have AT&T, 12 that have Verizon, 8 that have T-Mobile, and 2 that have other. Okay, so sometimes we can add an extra row called total. And total, we're just going to add that up, and we get 30. Now, let's say I want to create a relative frequency table. So anytime you have a relative frequency table, you're just going to convert your counts to percentages. So that's really the only difference. So my left table is still going to be cell phone carrier, the left column, but the right column now is going to be percents. Okay, and again, I have AT&T, I've got Verizon, T-Mobile, and other, okay? And if I want to convert these to percentages, I'm just going to take each individual count and divide by the total. So for example, for AT&T, I would take the 8 people that have AT&T and divide by the total, which is 30. So if you go on your calculator, and you will need a graphing calculator for this course, preferably the TI-84 Plus, because that's what I'll be using in class. If I want to convert a fraction to a decimal and then a percent, I'm going to take 8 and divide by 30, so numerator divided by denominator, and I get 0.26 repeating. And then to convert that to a percentage, you're going to multiply by 100, or just move the decimal 2 places to the right, which is essentially what multiplying by 100 does. So it comes out to about 26.7%. And you would do that for each of these. So we know T-Mobile is going to be the same because that's still 8, so that's 26.7%. And then I've got the 12 and the 2. So I need to convert those. So 12 divided by 30, and then multiply by 100. That gives me 40%. And then 2 divided by 30, and then multiply by 100. It gives me 6.7%. So I've got 40%, and then 6.7%. Now, if I add those, it may not come out exactly to 100% because of some rounding error. So if we wanted to be more specific, if we add those numbers up, 26.7 plus 26.7 plus 6.7 plus 40, I get 100.1%. So in order to avoid that, you could just carry more decimals over, so round to the nearest hundredth if you wanted instead, but it comes out to about 100%. Okay. There are certain visual displays or graphs that can be used for certain variables. So since we're dealing with categorical variables, you want to use specific graphs. And those graphs are going to be bar charts or bar graphs, pie charts or pie graphs, and segmented bar charts. And there's other ones, but those are just 3 to get us started. Okay, so it wouldn't be appropriate to use like a histogram, a dot plot, a stem and leaf plot, box plot for something that's categorical. We want to keep in mind something called the categorical data condition. And it just says in order to use those charts, like bar charts, pie charts, segmented bar charts, the data has to be counts or percentages of individuals in non-overlapping categories. Okay, let's take a look at an example. So in June 2019, the Gallup poll asked a representative sample of US adults how much confidence they had in various institutions in American society. The response about Congress is given to the right. So here's my table, okay, and it's a relative frequency table, and I know that because it's percentages. So what would be an appropriate display if I was to create a graphic of this? I can choose. I can make bar charts. I can make a pie chart. I would not be able to do a segmented bar chart. I mean, you could, but it would only be one bar, so it really would not be too useful. But I'm going to choose here to make a relative bar chart. And the reason I'm making a relative bar chart is because I have percentages. So I need a title for my graph, right? So if I look at this, it's basically asking me US confidence in institutions. Okay, I need a vertical axis, and I need a horizontal axis. My vertical axis is going to be my percentages. My horizontal axis is going to be the categories: great deal, quite a lot, some, very little, and none. Okay, so we can call that like feelings. And when you're creating a bar chart or a relative bar chart, it doesn't matter what order you put it in, okay? So I'm just gonna start with great deal. And if I look at that, it's 4%, and I go all the way up to 48%. So I'm gonna try to figure out like, okay, what should I count on my vertical axis? I just gotta make sure that I have enough spaces for everything, right? So the highest it goes is 48%. So maybe I just wanna count by tens, and I might just want to go up to 50. Okay, that'll give me enough space. You want to try to make sure it is equally incremented as best you can. Okay, remember these are percents. And I'm going to start out with great deal, which is 4%. So I know that 5 is halfway, 4 is like right underneath. So I'm just going to make sure that my bar goes to about 4. Okay, and that's going to be the great deal. Then I've got quite a lot, which is 7%, so that's going to go up a little bit past. Okay, that's quite a deal. And then I've got some, which is 36%. Okay, so I know that this is 10, 20, 30, 35, 36, so it's going to go like right about there maybe. Okay, and that's some. And then I've got very little, which is 48%. And then last but not least, I've got none, which is 4%. So I'd want that to be about the same height as the great deal. Okay, and you can color them in if you want. Notice that I am leaving spaces between the bars, okay? And the reason for that is because you could take the bars and interchange them. You don't have to have them in any specific order. There is a bar chart. It's called a Pareto chart, Pareto, that we don't really mention here, but the Pareto chart is like a bar chart, except the bars go in order from either increasing to decreasing or decreasing to increasing. So in other words, I could, stack the bars starting over here with the highest all the way down to the lowest. So that's what a Pareto chart does. Okay, you can feel free to pause the video now and try to do this next problem and then unpause it when you're ready to go over it. Using the cell phone carrier class data previously found, we want to create an appropriate visual display for that data. Okay, remember, your graph should always have a title, be clearly labeled axes, and sometimes a key. You can also use a key when you have like colors or special symbols used in the graph. And then you're going to write a few sentences describing the bar chart. So what do you notice about it? So if we go and we look at our information on cell phone carriers, right? I think the easiest type of graph to make would either be a regular bar chart, or you could do a relative frequency bar chart, okay? So since we made a relative frequency bar chart, why don't we make just a regular bar chart for this graph? All right. And it's okay if you did not do that. So again, we need a title. So cell phone carriers in maybe our class, SDA 2023. Okay, and then we've got our vertical axis and our horizontal axis. And this time I'm just going by counts, right? So this is going to be, my counts represent the number of students, and then cell phone carrier is going to go on the horizontal. So here I've got number of students, and then down here I have cell phone carriers. Okay. And I'm going to slide this up just a bit. All right. So we have, again, our AT&T. And then we've got Verizon, T-Mobile, and then other. Okay. And the highest number it went up to was 18, I believe. So let's just count by fives. We've got 5, 10, 15, 20. And actually, let's make that, spread those out a little bit more. Okay. Now, if I go to my table here, let me see if I can copy and paste it so that we have it down there. There we go. Okay, and I'll just shrink it down. So now we can just look at it. So AT&T was 8. And Verizon is 12. And T-Mobile is 8. So we'd want to make it the same height as the AT&T. And then other is 2. So there's our bar chart. And if we were to write a few sentences about it, what are some things that we notice about it? Well, I can see that the highest bar here is Verizon, which tells me that most students in the class have Verizon, right? So that's something important. And something else that I noticed was maybe the same number of students have both AT&T and T-Mobile, and the fewest amount of students have something other than those three. Okay, that is the end of this first part of this video. Please join me for the next video so that we can talk about pie charts and also look at other displays for categorical variables. Have a great day, everyone.